My dear friends, colleagues and students, today I am going to give the lecture on alloys and composite material. Approximately 80% of all elements in this world are metals and they have significant role in our daily life. They are used in industry, buildings, transportation, cooking, etc. And alloys are generally prepared by mixing metals in any ratio to form new substance with improved qualities from their parent metals. So alloys are little bit different from the compounds. Compounds, they are made by mixing elements in a fixed ratio, but here alloys are generally prepared by mixing metals in any ratio to form new substance, and they are having improved qualities from their parent metals, and they don't have the different properties from their parent metals. Alloys are solid at ordinary temperature and pressure. The force which binds together the atoms in alloys is called metallic bond. To account for the bonding in metals, Lorentz has proposed a model known as electron gas model or electron C model. This model is based upon the following two characteristics properties of metals. The metals have low ionization energy. They will lose the electron easily. And the second property is there are large number of empty orbitals in the valence shell. So using these properties, the metals are good conductor of heat and electricity. And similarly, as I have mentioned earlier in slide, that alloys are having the similar properties from the parent metals. The valence electrons are not bounded to any particular pair of atoms, but move freely throughout the metal and form negative electron cloud, which is shared by the positive ions. It has been observed that electrons in their outermost energy levels are loosely held by their nuclei. As a result of this, all the electrons in their outermost energy levels require very small amount of energy to detach themselves from their nuclei. So electrons are free as compared to other non-metals. At a room temperature, all the atoms lose electrons from their outermost energy levels, which form an electron cloud or common pool of electrons. The electrostatic force of attraction between positive ions and electron cloud forms a bond, which is known as metallic bonds. So there are metallic bonds are present in the metals and in alloys. Alloys have some very useful and good properties, due to which these are mostly used in agriculture, industries, transportation, homely things, and in medical surgeries, and in textile, in cooking. So they are have wide applications in agriculture, industries, transportation, homely things like food, cooking, or cycling, transportation in daily life. Most of these properties depend on the internal structure of metals. The most common properties of metals are discussed in the next slides. The electrical conductivity of a metal is due to the presence of mobile electrons. When a potential difference is applied to the metal, the free mobile electrons in the metallic crystal start moving towards positive electrode. Thus, the metal maintains the flow of electrons from negative electrode to positive electrode. This is the cause of electrical conductivity of the metals. So, there are loose electrons. So, when a potential difference is applied to the metal, the free mobile electrons in the metallic crystal start moving towards positive electrode. The metal maintains the flow of electrons from a negative electrode to positive electrode. This is the cause of electrical conductivity of the metal. The thermal conductivity of metal is also due to the presence of mobile electrons. When a part of the metal is heated, the kinetic energy of the electrons in that region increases. Since the electrons are free and mobile, these energetic electrons move rapidly to the cooler parts and transfer their kinetic energy by means of collisions with other electrons. Therefore, the heat travels from hotter to cooler parts of the metals. The thermal conductivity of metals and alloy is also due to the presence of the free electrons present in the metals and alloys. Metals and alloys shines, and the brightest luster of the metal is also due to the presence of mobile electrons. When light falls on the surface of the metal or alloy, the loosely held electrons absorbs photons of light and start oscillating at a frequency equal to that of the incident light. These oscillating electrons become a source of light which emit radiations in the form of light. As a result, the incident light appears to be reflected from metal or alloy surface, and the surface acquires a shining appearance which is known as metallic luster. Metals and alloys, they shine, and the bright luster of these are also due to the presence of the mobile electrons. Alloys and metals can be beaten into sheets and drawn into wires. These properties are exhibited by metals or alloys due to the non-directional nature of metallic bonds. When any stress is applied on metals or alloys, the position of metallic kernel is altered without destroying the crystal. Due to the slippage of the adjacent layers of kernels from one part to another, the metallic lattices gets deformed. The deforming forces simply move the kernels from one lattice site to another, and due to this property, the metals are malleable and ductile. They can be beaten into sheets and drawn into wires. Due to this property, they have wide application in our daily life. For example, in construction work, industry, transportation, electrical conductivity or heat conductivity. So, the property of malleability and ductility has wide application in our daily life, construction work, industry, transportation, and in electrical or heat conductivity. Alloys and metals have high tensile strength. In other words, metal can resist stretching without breaking. It is due to the presence of strong electrostatic forces of attraction between the positively charged kernels and the mobile electrons surrounding them. Alloys and metals have high tensile strength. Metals and alloys can resist stretching without breaking. These are due to the presence of strong electrostatic forces of attraction between the positively charged kernels and the mobile electrons surrounding them. Metals and alloys are generally hard. The hardness is due to the strength of the metallic bond. In general, the strength of the metallic bond depends upon the following two factors: number of valence electrons. Greater the number of valence electrons for delocalization, stronger is the metallic bond. So, if they are having number of valence electrons, there is a greater the number of electrons for delocalization, and there is stronger is the metallic bond. Size of the kernel: smaller the size of the kernel of the metal atom, greater is the attraction for the delocalized electrons. Consequently, stronger is the metallic bond. So, these two factors, more the number of valence electrons and smaller the size of kernel, gives us hardness in the metals and alloys. Metals and alloys are opaque to light. The light cannot pass through them. This is due to the presence of free electrons in metals which absorb light energy. So, metallic luster and opacity is also due to the free electrons in metals and alloys which absorb the light energy. The metals are obtained by pyrometallurgy and the alloys are obtained by mixing the different types of metals. So, metals are obtained by pyrometallurgy is the process of extraction of metal from its concentrated ore by heating it to high temperature. At high temperature, the ore is generally converted into metal oxides, which is then reduced by smelting to crude metal. So, when we heat the ore at high temperature, the crude metal oxide or the crude metal is obtained. The crude metal is little bit impure. Crude metal is subject further for refining to get pure metal. For example, zinc, iron are extracted from their ores by pyrometallurgy process, and they are further purification is done by further heating these metals. Electrometallurgy is the process of extraction of metal from its concentrated ore by passing electric current through the solution of the ore or through the ore in the molten state. So, aluminum is extracted from its ore bauxite by electrometallurgy. So, when electricity is passed through the concentrated ore, we will get aluminum in the molten state from the bauxite ore. So, this process is known as electrometallurgy. Hydrometallurgy is the process of extraction of metal from its concentrated ore by dissolving the ore in a suitable solvent. So, ore is the mineral from which we will get economically metals. So first the ore is dissolved in the suitable solvent, then filtered the solution, and then precipitating the metal by adding suitable substances. For example, copper is extracted from its low grade ore like malachite of azurite by hydrometallurgy. The extraction of metal from its source involves individual process which depends upon the nature, its physical and chemical properties. As the metals differ in their physical and chemical properties, they have different methods of extraction. However, following steps are generally involved in the extraction of metal from its ore. So there are 5 or 6 points which helps in the extraction of metal from its ore. These steps are: first step is crushing of ore. So first ore is crushed into powder form by using hammers. Second step is pulverization of ore. Third step is concentration of the ore. Fourth is calcination, and fifth is the roasting of the ore. Sixth step is reduction of the oxide to free metals. So this is also known as smelting. And the seventh step is refining of purification of the metal. So there are 7 steps by which we will get metals from the ore. So I repeat again: first step is crushing of the ore. Second step is pulverization of the ore. Third step is concentration of the ore. Fourth step is the calcination of ore, and fifth is roasting. Here in roasting, the ore is heated in the presence of air, while in the calcination the ore is heated in the absence of air. So sixth step is the reduction of the oxide to free metals. So oxygen is taken away from the ore and free metal is obtained by reduction. And seventh step, in sixth step we will get a crude metal. So further refining or purification of the metal gives us 100% pure metal. The ore obtained after mining is in the form of big lumps. These lumps are converted into smaller pieces. This is called crushing and grinding of the ore. This is done with the help of jaw crushers and grinders. The crushed big pieces of the ore cannot be directly used for the processing of metal. These should be reduced to fine powder. This process of grinding of the crushed ore into fine powder is called pulverization. For this purpose, mostly stamp mills are used. It consists of heavy stamp or bolts which rises and falls on a hard die below, on which crushed ore is fed from one side. So pulverization is the process of ore to get fine powder. So big pieces of the ore converts into the fine powder. Concentration of ore. The ores are associated with impurities like sand, clay, limestone, etc. The rocky unwanted impurities present in an ore are called gangue or matrix. The impurities present with the ore, these are known as gangue or matrix. The removal of these impurities from the ore is called concentration of ore or ore dressing. The purified ore is called concentrate. The process of concentration of the ore is carried out as follows. Number one, hand picking. Second is washing. Third is froth flotation process. Fourth is magnetic separation. Fifth is leaching. So there are 5 steps to get the concentrated ore. So we need concentrated ore for economical reasons. If we are not concentrating the ore, then the cost of the metal is very high. Calcination is the process of heating an ore strongly below its fusion temperature. In the absence of air or limited supply of air, generally non-sulfide ores are subjected to calcination. This process removes the volatile impurities from the ore. It further removes moisture from hydroxides and hydrates. For example, zinc carbonate, when heated in the calcination, it converts into zinc oxide and carbon dioxide. Similarly, the ore of the copper, it converts into the copper oxide and carbon dioxide, and water, it also removes moisture from hydroxide and hydrates. Process of heating the ore in the presence of air at its fusion temperature is known as ore roasting, and it converts ore to its oxide. It converts metal ore to its oxide. The ore is normally a sulfide and is heated to a temperature below its melting point. This process dries the ore, dries out the volatile impurities, non-metals, sulfur, phosphorus, arsenic, carbon, silicon. These impurities are removed by roasting. It converts a sulfide into sulfur dioxide, phosphorus into phosphorus pentoxide, and it converts the ore to its metal oxide. The calcinate or roasted ore is further treated for its reduction to free metal. This may be done by any of the following methods: smelting, reduction by hydrogen, reduction with carbon monoxide, reduction by highly electropositive metals, reduction by electrolysis, amalgamation. So from metal oxides, oxygen is taken away, and this is done by reduction. So there are 5 steps. So number one step is smelting. In smelting, the ore is heated with some flux, and that flux takes away the oxygen. So hydrogen also takes away the oxygen. So similarly, carbon oxide and hydrogen, they take away the oxygen from the metal oxide and liberates the metal into the crude form. So reduction by highly electropositive metals. So reduction by electrolysis when we apply the electricity. So by electrolysis we are getting aluminum from the bauxite. So these are the process. The metals obtained after reduction may still contain some impurities like other metals. These may be originally in the ore, present in the ores. Unreduced oxide of the metals may be they are still present in the metal, crude metal. Non-metals left during the reduction in the furnace, for example, silicon, carbon, phosphorus. Substances like slag, flux taken up from the surface. Therefore, refining of the metals may be carried out depending upon the nature of the metals and the impurities. Some of these methods are as follows: liquefaction, distillation, oxidation, poling, electro-refining, zone refining method or chemical methods. So using these methods we will get pure metal. As discussed earlier, alloy is generally a homogeneous mixture of two or more elements, out of which at least one is essentially a metal. Pure metals are seldom used as engineering materials as they do not possess the required physiochemical and technological properties for some definite purpose. Alloy is a mixture, it's not a compound. In compound, the elements combine together in a fixed ratio and they have different properties. But mixture have the same properties as from their parent mixing materials, while compounds they have different properties. For example, carbon burns and oxygen helps in burning. The compound carbon dioxide it extinguishes the air. Similarly, hydrogen burns and oxygen help in burning, but when they combine to form water, which is a compound, it also extinguishes the fire. But alloys they have the same property from their parent metal. Pure metals are seldom used as engineering materials as they do not possess the required physiochemical and technological properties for some definite purpose. To impart the desired properties, pure metals are alloyed with other metals and non-metals. Some examples of alloys are brass, bronze, cast iron, and alloy may be either homogeneous or heterogeneous. An alloy of coinage silver is homogeneous. It consists of small crystals, grains, each of which is a solid solution of copper and silver. Heterogeneous alloys consist of a mixture of different phases, which may be pure metals, one or more pure compounds, or solution of the metals or their compounds in metals. From the engineering point of view, the alloys are generally known as ferrous alloys and non-ferrous alloys. All alloys available in the world are ferrous or non-ferrous alloys. Ferrous alloys are those which are having iron one constituent, and non-ferrous alloys are there is no iron present in these mixtures of metals. So there are two types of alloys: ferrous alloys and non-ferrous alloys. So in next slide we are going to discuss these categories. Alloys of the iron are known as ferrous alloys. Iron is used as the essential part in making these alloys. Mild steel, which is obtained by mixing iron with carbon. The presence of carbon is 0.15, 0.3%.